Okay, hello. This is Ahmad Qadri. I'm one of the instructors for MAT 243, and I have with me Juan Hernandez. Okay, great. So, Juan, the first thing I think I would want to know is what are some of the tutorials for this course? Where can I find them when I'm in this course?
Yes, let me refer you, if you were to click on course menu and go to learning modules, we will then select module 1, and in module 1 you're going to find the links to several features. One of them is tutorials, 1-1 tutorials. So we will click on that, where you will see some of the tutorials that are available. Especially on this page, you will find zyBooks and the zyBooks activities, guidelines, and rubric.
So, what are zyBooks?
The zyBooks is the text that you will use to see all the activities that you can do for every module. Your assignments will be based in zyBooks.
Ah, okay. So this is kind of like a textbook, except it's not a hard textbook. It's a electronic sort of interactive textbook. Is that right?
That is correct.
Okay, very good. So these are some of the tutorials on that. Okay, what else is there?
Well, let's go back to module 1, and you're going to also see the resources available for the course have additional links on the resources that will show you the assignments and additional tutorials.
Okay, very good. So what is this course about?
This course is about statistics and statistical applications. If you look at your syllabus, you will see all the topics as well as Python and how can we utilize Python to run statistical applications. So you will learn both statistics to make predictions and decisions and other features, as well as Python to make those calculations. And one of the most important things you will learn to do in this course is to interpret the data and the meanings of the results that you get in Python. Python is just a tool to make the calculations. However, you also need to know what those results mean and how to properly interpret them in the real world.
Okay, very good. So what are some of the assignments for each week? And I suppose I'm starting in week one, so I am much more interested in knowing, what do I have to do for the week?
Okay, so you come to module 1. In module 1, you click on resources, and then we will see the assignments. Those assignments will be based in zyBook.
Okay, and I see that when I clicked on resources, I'm able to see the sections I have to read in zyBooks, and these are nicely linked, so I can actually click on it. We have Jupyter Notebook, Codio tutorial. That's pretty good because Jupyter Notebooks will be used to do the Python code. And then there's a resource here, how to use zyBooks. So that just explains how the textbook works.
Yes, and in addition to that, there is a brief summary as to what is expected on the discussions. And finally, an important thing is that you want to be learning the Python functions that support the statistical calculations that correspond to every module. And you can see that those functions are listed below, and they are also linked, so you can learn more about these particular functions.
Okay, that's very good. And I can actually recognize some of these, like the mean or the median, min, max. Very good. Um, One thing I do want to note here is, as you will see, the sections here listed are for Zybook. These are the Zybook reading sections. And you'll see that some sections we're skipping over. So like there is sections 1.5 and 1.6 are not covered. This will be the case each week. So some sections are optional for you to read. And I think Juan and I agree that we encourage you to read them. They will add a lot of knowledge in addition to what you will be learning in the course, but they are optional after all. So if you are sort of short on time, then just make sure that you go through these sections that are listed and finish the activity questions in these sections. These are the sections where you will be graded. Okay, very good. So I suppose I have a Zybook assignment for this week. I have a discussion forum for this week. And then is there anything else that I have to do for this week?
Well,
So,
it's always good to review everything listed in Module 1. In addition to the discussion and the Zybooks, you will note that there is a quiz that has 5 questions. You are supposed to also complete this assignment by clicking on that link and following the instructions.
okay, very good. So each week I will have 5 questions to do. And these questions, as you can see, it says Python functions and probability. So the first quiz is on the Python functions that we will use in week 1 and some of the concepts on probability that we will be learning. Okay, so Professor Juan, how do we get to Zybooks so that students can do their homework assignments?
Okay, so we will go to Module 1 and click on Resources, and that will put us into the list of activities in Zybooks. So you can click on Sections. Those are the sections due for week 1. And for example, let's go to 1.1, and you can look at the activities that you need to complete.
Okay, so this is basically the reading assignment. Students will read the sections here, and then here is the participation activity. So these are, I am assuming, the homework questions.
That is correct.
Okay, and then as we saw, the sections to complete for week 1 are 1.1 through 1.4. Then we skip 1.5 and 1.6. Then we have 1.7 to 1.10, then 2.1 to 2.3, and then 3.1 to 3.3. So these map to sections in Zybook. So as we know, we're going to have to read this for the week. And then to go to the next section, we'll scroll all the way down. And then here's a link for the next section. What is data visualization? If we click on Math 243 right here, which is the name of the textbook, it takes you to the table of contents. And to expand chapter 1, for example, we'll just click on this. It expands and shows the sections to read and their numbers. And as you can see, the sections to read are 1, 2, 3, 4. Then 5 and 6 are optional, so students don't have to read those. And then sections 7 through 10. And then similarly, here's chapter 2, 1, 2, and 3, and then probability and counting. Again, we're only covering 1, 2, and 3, and then 4, 5, and 6 are optional.
By the way, one important observation is that it would be very useful to do the Zybook activities before engaging into the discussions, because this gives you the background to write your report on the discussions. Secondly, you will also become familiar with the Python libraries. Remember that they are listed in the instructions for Module 1. So you want to complete your Zybook activities. You also want to become familiar with the Python libraries, and then you will be ready for the discussions. Okay, so now let's work with Professor Kadri and find out how do we prepare for our discussions and how do we do them. And let's look at the first step. What should I do first to prepare for a discussion?
Okay, very good question. So each week there will be a discussion that will require an initial post by Thursday of the week and 2 response posts by Sunday of the week, which is the last day. Now, the first thing to do for discussions is to make sure that you have read the Zybook sections. It's always good to read them early in the week so that you are ready to do your initial post and also to get a head start on the homework assignment. This will especially be useful when we get to later weeks when the projects are due, because the projects are a little comprehensive, and it's always good to be ready earlier in the week than leave the readings to the later part of the week when it gets a little harder to understand these different concepts. So the first thing again to do is to just make sure that you've read Zybook sections for the week, and then what we will do is we'll go to module 1, for example, in week 1, scroll down, and you'll see that for discussion there are 2 very important links. One is called Jupyter Notebook Discussion Prep. This link opens up the Jupyter Notebook where the discussion Python code resides. So that's where students will be running their code. This link, 1-5 discussion descriptive statistics, is where is a link to the discussion forum. This is where all of the questions are posted that students will need to address in their discussion posts. And my recommendation is to always go here first, 1-5 discussion, descriptive statistics in week 1. So always go to the discussion forum of the week first, read out the questions, and then go back and go to the Jupyter Notebook. So let's start with this link first. I'm going to open this in just new tab. And so this is the discussion forum. Another way to get here, by the way, is to go to course menu and click on discussions. This is a list of all of the discussions in the course, including the getting started general questions. So once we scroll down, we see that there is the 1-5 discussion, descriptive stats. This is the same as the week 1 discussion. So Juan, as you know, we are covering descriptive statistics in week 1. And it's very important to read all of the questions here and the directions before doing the initial post. So for example, we'll start here. So it says use the link in Jupyter Notebook activity to access your Python script. And once you have made your calculations, complete this discussion. The script will output answers to the questions given below. You must attach your Python script output as an HTML file and respond to the questions below. So continuing here, we have for this discussion, you will collect data from a public source and calculate descriptive stats, including measures of central tendency and variability. You will then interpret the results. In your initial post, use this website or a similar website of your choice to find the daily maximum temperature data in your city or zip code for the past 14 days. And you will use this data set to calculate measures of central tendency and variability And then here are the questions. So all of the questions are grouped in an initial post questions and then the follow-up post questions. So for example, in the initial post, these are the questions to address. And in the follow-up posts that's due on Sunday, last day of the week, these are the questions to address. Okay, so for the first post, here are the questions. And let's just quickly go through them, and then we will see how we can answer them in the Python script. So share your data set. The first thing to do is obviously go to this link or any link, any weather website link of your choice. Find the daily maximum temperature data in your city for the past 14 days. So you'll have a data set of size 14. And just share that data set in your initial post. And you'll see that each question has a reference to the Python script. It tells you what step in the Python script you need to look at to answer that question. So this is a good time now for us to go into the Python script in Jupyter Notebook to answer all of these questions. So let's go here and then let's go to Jupyter Notebook. So once the Jupyter Notebook link for Module 1 discussion opens, here's what you will see. But this is not the Jupyter Notebook. This is just a README file. So each time you open the notebook link, it'll likely take you to the README file. And the way to open the Jupyter Notebook for any discussion, in this case week 1 discussion, is to look at the file tree on the left side of the screen and look for a file name called module1discussion.ipynb. So here it is. So I'm going to click on this, and this will open the Jupyter Notebook for week 1 discussion. It also has directions for each step and then the Python code associated with that step that students will be running. So it is very important to read the instructions given in each step before running the code, because in a lot of cases the instructions will tell students how to edit the code so that it runs without any errors. And also notice that these steps are the ones that were referenced here in the discussion forum for week 1. For example, remember we said the first question is to share your data set, see step 1 in the Python script. Well, here's step 1, preparing the data set. The second question is, what were your descriptive stats for this data set? Report the mean, median, variance, and all of these statistics. See step 2 in the Python script. Well, here's step 2, calculating descriptive statistics. So as you can see that the Jupyter Notebook is linked with the discussion for the week, specifically the questions. Each time there's a question, it tells you exactly which step in the Python script answers that question. So let's go back to the first question, share your data set, see step 1 in the Python script. So here's the first step. This block of Python code will generate the sample data in a Python data frame that will be used in the calculations later. Your task is to use a website to collect daily maximum temperature data for your city or zip code for the past 14 days. Then input your data in the code below by filling in the Python list. After entering your data in the Python list, click the code section below and hit the run button above. Okay, so two very important things here. First, it says fill in the Python list. So what is a list? So a Python list is essentially just a data type that is used to input a sequence. And the sequence can be numbers in this case. And one example given is right there. So this is a Python list, and the name of the list is temperatures. So temperatures has a sequence of numbers that's given here. So the task here is for students to figure out the maximum temperature data for the last 14 days for their city or zip code, and then they have to enter their data here. Okay, so let's just assume that we have the temperature data given here as the last 14 days, temperatures for the last 14 days. So I'm just going to copy this and I'm going to edit this here and I will paste it. So this is now a list that has the temperature data for the last 14 days for my city, and after I've done this, I can just simply run this code section. So how do I run this code section? Well, I will just highlight the section and there's a run button here and I will click that. And here it is. So it prints out the same data, but in the form of a Python pandas data frame. So what is a data frame? A data frame is essentially just it's a two-dimensional data structure that shows data in a tabular fashion in rows and columns. So for example, the column here is called temperature, and this column contains the temperature, and these are the different rows. And the rows are indexed by the number 0. So they start with 0. So there are 12 rows in this data. That's clearly 2 less than what we need. We need 14 in this case, but everyone gets the point. This is how you enter the data in a Python list. And then we create the data frame using this line here. And then we simply just print that data frame.
Professor Kadri, how did you highlight the sections? What should I do to highlight it before pressing the run button?
Very good. So we see here this section, this part of each section, we can just click on them to highlight that section. So for example, see, I can click here, that highlights this. I can click here, highlights this, and then I can click here and this highlights this section. Very good question. Highlighting the comments here and hitting the run button will not obviously do anything because those are just instructions. But highlighting the coding section and hitting the run button will actually run the code. Now let's say that as you saw that we only had 12 data points, but we needed 14. So clearly we need to add two more numbers here, and we can do that two ways. So let's say that we just add the two numbers. So I've edited the list again. I'll highlight this part again and I'll hit run. And now you can see that it added the numbers that I just added to the list here to the data frame. So now we have 14 rows. Now let's say you want to, for some reason, you don't want to see this output here. So let's say I want to clear this output and run this again. So how do I clear this output? Well, I can again click this section. I will go to cell, all output, and I'll hit clear. And it just clears all of the outputs in the script. If for any reason we want to clear just this part, just this output, I will again click on that section, cell, current outputs, clear. So this will only clear this output. Okay, so we have our Python list ready. I will run this again. I get my data set in a data frame, and then I go back to the discussion and share your data set. Well, this is my data set right here. So this is something to include in the initial post. Now let's go back. What were your descriptive statistics for this data set? Report the mean, median, variance, and standard deviation. So based on this, what can you say about the distribution of temperature in your city or zip code? So let's first run, as you can see here, it says C step 2 in Python script. So let's run step 2 in the Python script. This block of code below will calculate descriptive statistics for the data set you entered. Pandas data frame has several methods that calculate descriptive stats. Each method has a comment telling you what that method calculates. So you can see here, temperatures df is the data frame, is the name of the data frame that has the temperature data. And temperatures df is referenced here as well. Inside temperature df, we have the column name, temperature, and here are the methods that calculate different statistics. So, okay, so maybe it's a good idea right now to do maybe an example and show how these mean, median, variance, and standard deviation functions work and what kind of a message they give as far as analyzing a data set is concerned. What do you think?
Yes, absolutely. Let's go ahead and do that.
So what I will do now is let's open a practice Jupyter notebook so I can show some code and how to calculate some of these descriptive statistics and what do they mean? What do the numbers mean that we will output? So everyone has access to a practice Jupyter notebook, and students can access that by going to the assignment information and then scrolling down all the way and then having, clicking on this link called Practice Jupyter Notebook. So now I'll look at the file tree here and look for the Practice Notebook. So I click on that. And this opens up a Practice Jupyter Notebook. So I thought it would be good to run a few examples here and then explain what do the statistics mean. So I'm going to call this temperature 1 data. And then, so let's now create a data frame for this. Okay, so I'm just going to call this temp1 df. And before I create the data frame, I should import the pandas library or module. And let's print this data frame. Okay, so this is my data frame. Now let's say that I want to calculate, say that I want to calculate the mean. And now let's print this. I'm going to print the mean. Let's call this mean value. So the mean, when it's calculated, is calculated in a variable called mean value, and that's what I'm going to print out. There it is. So here's my data frame. This is my data, and this is the mean. So 65.1 is my mean. Now let's, Juan, how about you pick a data set of your own? So we'll pick that here. Call this temperature 2. So those are your 10 values. Okay, so I will now again create a data frame for Professor Juan's data. And I will calculate the mean value. Let's print this. So here's this data set, and the mean here is 85.6. Okay, so clearly there's a big difference between the two means. Now, how about we also calculate the median? So let's calculate the median. I will run this, and I get my median as well. Now, for now, I'm going to just suppress this data frame output because I know what my data is. So I'm just going to comment that out. So now I only have my mean and the median. So Juan, what do you notice about the mean and the median for my data set?
They are very close to each other, so it seems that this falls into the characteristics of the normal distribution.
That's right. And students will be learning the normal distribution next week. But essentially, this looks like the data is, if we were to plot this data set, it seems like it is going to be a bell-shaped kind of a distribution. So let's do the same, calculate the median for your data set. Okay, so what do you notice about your data set?
Is even a little bit more, well, no, it's both 85. So it's very similar with a small variability.
Right. So how about we create some variability in this data? So let's say that for some reason in Florida, temperatures are changing drastically. So maybe there's a 60, and then maybe there's a 102, and maybe there is 55 in there. And for some reason, there's 110. So now you can see, what do you see now?
The variability has increased.
Right, so variability has increased, but also that the fact that the median is now greater than the mean. This data set compared to my data set is skewed. Now, where is the skew? Generally, you'll notice that the mean tells you the direction of the skew. So in this case, the mean is less than the median. So the skew is going to be on the left-hand side, meaning there are more lower values than there are larger values. So for example, let's say that this 60 for some reason was coded incorrectly, and so for some reason it was coded as 10. So now we have a very small value here, 10, compared to all the other values that are between 70 and 110. If I run this, you'll see that the mean decreases even more, right? The mean has now gone down to 78.2. Well, that's because we entered this very low value that's pulling the mean in its direction. But notice the median is not changing, right? The median remains the same because the median is generally resistant to any outliers. And if you have a skewed data set, the median will generally not move as much as the mean will. So looking at these two data sets now, if we were to only consider measures of central tendency, the mean and the median, what can we say about these two data sets?
Well, when there is consistency in the data set, the mean will be a better measure to identify the central tendency. However, if you have outliers, such as the value of 10, then the median will be a better value for central tendency.
Absolutely right. That is correct, because the median, again, is resistant to any outliers or that cause skew in the data set. So in this case, I would prefer to use the mean, but in this case, we should use the median because this data is skewed.
And I want to emphasize at this point in time that the discussion that we had is a very good example of interpreting the data. This is what interpretation is all about. One approach is that students report the mean and the median. You just state the values. However, that does not deal with the concepts and the true meaning of the terms. So this is how you can connect this to what is explained in ZyBooks, and then you can also read about it with additional resources. But this is the foundation that you need to develop, not only for what Python calculates for you, but what does it mean in the real world.
Correct. And those are the kind of questions students will be answering. For example, here the second question was, based on these statistics, what can you say about the distribution of daily maximum temperature in your city or zip code? Use all of the statistics you calculated. So part of the analysis will be what we just explained, whether there are outliers in the data, and if there are outliers, are they causing skew, which direction they're causing the skew in, and if there is skew in the data set, then should we use the mean or the median to represent the center? Very good. So let's now calculate the other two important statistics that are for variability, the variance and the standard deviation. And so my variance for the data set is 8.1 and the standard deviation is 2.84. Now let's run Professor Wan's data set and see what the variance and the standard deviation is there. So the variance is 787 and the standard deviation for Professor Wan's data set is 28.07. So Wan, what can we say about the two data sets based on the variance or the standard deviation being that different?
Well, we can basically, when you see a large difference in variability, similarly to what we saw with the mean and the median, it means that as a result of the outlier, the value of 10, you need to decide whether you want to include the outliers in your data set, if it was truly an outlier, to gain consistency. If the outlier is real, then it basically expresses that there is a significant amount of variability between the two data sets.
Exactly right. So it's also very intuitive to notice that if the temperature in a given city is somewhat consistent, not changing too much, then the variance is 8, but you have the second data set where the variance is 787. That's a huge difference. So clearly, just by looking at the variance, we can figure that something is wrong with the data set. So if the variance comes out to be a very large value, then it's the first thing to note is to look at the data set and make sure there are no outlying value that just stand out. Like in this case, 10 is a clear outlier. So measures of variability are very good at catching that. So this sort of answers the second question in the initial post, how students have to use the statistics and explain their own data sets and the distribution of their own data sets. So now let's go to this third question. Which graph showed the general trend of the temperature in your city? See step 3 in the Python script. So we'll go back to module 1 discussion notebook and let's go to step 3. So here is step 3 and let's run this. This is going to create a line graph. Now sometimes what happens is when I try to run the graph, it gives me this output. Figure size is this with 1 axis. What it means is it has actually created the plot. It just did not output it here. This is an anomaly. It happens every now and then. And whenever this happens, note that there's a comment here. It says, if the graph is not created, click the code section and hit the run button again. So I'm just going to click this code section again and hit the run button, and it will output the graph. So every now and then it does not do that. And if it doesn't, just highlight the section again and hit run. So here is the general trend of temperature data. So Juan, what can you say about the trend looking at this graph? Seems like it's hovering between 70, maybe it's 78 till 88, and then what can we say about the data by looking at this graph?
Well, this is the trend line is also called a time series. And a time series include components of growth. For example, if you compare the level of the first data value, a little bit below 82, to the large, the last point, which is about an 83 or so value. So you can see in terms of, for example, using the data for predictions, what is the trend? Is the trend growing or is the trend decreasing? Secondly, the fluctuations might be due to seasonal points. And then also you can see if there are any cycles. This has a little shape of a cycle, which depending on what time of the year you're taking these readings, it might be impacted by that. And finally, the last component is due to random influences, things that are hard to explain. They're just random changes that have no particular way of explaining it.
Okay, very good. And that pretty much answers what should be included in this part. So the question really was which graph showed the general trend of daily maximum temperature in your city. Just make sure to explain the trend a little bit, just as Professor Wan explained the trend that this graph shows. So the next question is, how are the measures of central tendency and variability used to analyze a data distribution? So note that there is no step included here. So this is just for students to explain how do we use measures of central tendency like mean and the median, and variability like variance and the standard deviation to analyze a data distribution. Professor Wan and I have covered that in this video, so just make sure to explain or to answer this question in terms of the skew in the data due to outliers. If there is no skew and the data is following a bell-shaped kind of a curve, then what kind of measures do we use? What do the measures of variability explain? Variance and the standard deviation explain how far apart the values are relative to the mean. So those are the things to include here. And the last question for the initial post is, the Python script also provides you with temperature data for a city called Zion. So this is a data set that we have created, and so you don't have to pick it. You don't have to pick this data set. This is created for you. Which graph show the difference in the distribution of your data and Zion's data? What can you say about the differences? See step 4 in the Python script. So let's go to step 4. So here's step 4. As you can see, there's a lot of code here, but you don't need to change anything. Most of this code generates the data set for the city Zion, and then we'll see what the output does. So let's run this. And the output shows a box plot for comparison view. So a box plot gives you a very high level view of the distribution, and we can use side-by-side box plots to compare the distribution of two different data sets. So for example, you can see here this Zion data, this box plot here is related to the data set for Zion. This my data box plot is the temperature data that you picked in step 1 of this notebook. So what kind of differences do we see? This line shows the median. You can see that the median for the case of Zion is higher than your data. And then just looking at the overall distribution, one can clearly see that this distribution for Zion tends to vary a lot as compared to the distribution that we picked in step 1 of the Python script. Now, when you pick your temperatures, it may be that yours are going to vary a lot more. Probably not, but If it does, that's okay. You just have to explain by looking at this side-by-side box plot, what kind of differences do you see in the distributions. You can also see that this distribution has more variability than this distribution. The values tend to vary a lot more here as compared to here.
This is a very good way to summarize and see graphically the differences that we just explained between Professor Ahmad's data set and my data set. This is a graphical way of summarizing those differences.
Okay, very good. So this covers the last question of the initial post. So in the initial post, these are the questions that students need to address. Again, this post is due by Thursday of the week. And then we have these follow-up posts. But before we go there, I do want to show you, if we scroll down here, the script will also tell you that this is the end of the initial post. And then what students need to do, because there are no, for the follow-up post, it simply says to return to Module 1 discussion to answer the follow-up questions. So there's no code to run after Thursday. There are only questions to answer that are in the discussion forum. However, for the initial post, students do need to download this notebook with the outputs included. So for example, we should run this. So these are the descriptive stats for the temperature data. So with these outputs shown here, students will need to download this notebook and attach it to their initial post. How do they do that? Well, it tells you the HTML output. So the output should be an HTML, and it can be downloaded by clicking File, Download As, and then HTML. So File, Download As, and HTML. So this will download the file here, and you'll have to navigate to wherever it downloads it, and then attach it to your initial post in the discussion forum. Let's just open this HTML to see how it looks. So here's the HTML output. You'll see that it includes the code, the instructions, but it also includes your outputs. So instructors will be able to see that you run the code, that your output, the answers in your output match the answers that you reference in your initial post. So this should be attached to the initial post in the discussion forum. And then the follow-up questions that are due on Sunday are, how do your peers' measures of central tendency compare to yours? So you just have to pick 2 other students and then review your answers against their answers, and then just answer these questions.
I do have a question. I noticed that, for example, you made a couple of simple mistakes when typing the code in the practice notebook. Suppose that I messed up in my file and I'm totally frustrated and I would like to start all over again. Is there a way to do that?
Okay, so that's a good question. So let's say I make a mistake in the script somewhere. I forget that I need to include a bracket here so that this list is not complete. If I try to run this part, I will get an error. And let's say that I'm not sure why this error is coming up. I don't know how to edit the code, so, or how to take this code back to its initial state so that I can edit this again and not lead, that would not lead me to this error. So how do I do that? Well, in the file tree, you'll notice that there's a file called backup module 1 discussion .ipynb. So that's also a notebook, and it's a backup notebook. So if I click on this, it opens up the same. It's just like the original module 1 Jupyter notebook. It's exactly the same copy. However, in this backup copy, you will not be able to edit anything. Okay, so you'll only be able to copy and paste a section somewhere else. And that's what this is meant to be. The idea here is that because you made a mistake in the Python code for step 1, and we're not sure how to take this to its initial state, so we will just be able to copy the code section for step 1 from the backup copy. I will copy it. I will go back to the original Jupyter Notebook for Module 1 discussion. I will highlight this whole section. I'll right-click and then paste. Okay, so this takes the code in the initial state. And now I can enter my data again. So I'll just copy this from here. I will enter it here. And I will run it. And so now I don't have that error. So the idea of the backup is to simply be able to copy and paste sections of code where you've made a mistake and you're unsure how to take that piece of code to its initial state. Okay, so I think that concludes the first this video. This is the first video in a series of videos we're going to do for each week. We're going to focus mostly on the discussions as well as the projects when we get to them. And if there are any other questions about the contents or the discussion or how to navigate through the course, please direct them to your instructors. And we will see you next week.